Hello and welcome to episode 10 of the inventory tutorial series. In this video, we're going to rework how the items are stored in memory and how we save them out. So by the end of the video, not much will have changed in the editor. I'll be able to, go over here and put stuff into the chest just as we always have been able to. And we can hit save. But now, as kind of pointed out at the end of the last video, if I built and run this version of the game, I wouldn't be able to load that save in the built version of the game originally. But by the end of this video, we will be able to do that. So you can see here, we're in the built version of the game, and we can now hit load, and the save files are in sync between the actual built version of the game and the editor version as well. We'll be able to go over here, make some changes, go into this chest, put this thing here, put some tomatoes in the player's backpack. We can hit save, we can go back into the editor, hit play, and our save files will be in sync. So you can see there's our tomatoes, and each of the chests has what we put in it. We'll be creating a database that controls all of our items and assigns the items an ID as well. So let's just get started with the video. Okay, so let's get started. Let's go over to our item scripts folder, right click, create C# script, and we'll call this database. And let's open up that in our IDE. So this is going to derive from Scriptable object. So we'll get rid of start and update, and we'll replace mono behavior with Scriptable object. Now we're going to need to be able to right click and create a database in the project. So let's do create asset menu. And we can say menu name is equal to inventory system / item database. Let's just zoom in a bit. So we've got our database object here. So the first thing I'm going to do is serialize field a private list of inventory item data. So these are the other scriptable objects that we have. And I'm just going to call this the item database. Also, since starting this project many months ago, I've upgraded kind of my naming conventions to fit more in with how C# should be coded. So you'll notice that here I've got privates without an underscore. And you can see Rider is complaining, saying it should have an underscore. So it doesn't really matter, but that's why my naming conventions have changed. So I'm putting underscores under private variables, just so you're aware. So this is going to be a list. This is our database. This is the list of all of the items in our game. And this is kind of like the one sort of point of truth. So when we load in a game, we can look for an ID instead of the instance ID, which, as I said last time, can change between builds and the editor and patches and updates. Like, it's not very safe. This way, we can assign an ID to a item, say like 1, 2, 3, and then our save file can say that we've saved item 3, and item 3 will always be item 3. It won't change in between. It won't change in between sessions, and it'll go between the editor and the build will share the same item database. So we'll be able to load our save games that we've made in the editor in a built version of the game, and we'd be able to load the save file that's in a built version of the game back up in the editor, which would be great for debugging and stuff like that. So with that said, with that little bit more of an explanation out of the way, we're going to make a function to actually set these IDs. So I'm going to do a public void set item IDs. And I'm going to, above that, give it the context menu attribute with the set IDs name. So we can call this in the inspector if we need to. So the first thing I'm going to do when we set some item IDs is I'm going to create a new list of inventory item datas. This will just ensure that the database is never null when we start to try and do stuff with it. And the first thing I want to do is I'm going to make a variable called found items. And I'm going to search the resources folder by calling resources load all. And I'm going to get it to load all of the inventory item data that we have in our project. And this is going to be at the path of item data. And then I'm going to use system.link. So let's come up here. We'll do using system.link. And we're going to order all of our items by their ID. So if, say, apples is an ID of, so if tomatoes is an ID of 1 and potatoes are an ID of 2, it will put them into that order. So it'll put tomatoes first and then potatoes. So we can do order by. And the way the order by function works is quite easy. So we need a letter or a variable name, because this is almost like doing a for each loop. So we're saying for each I, or this can be anything. This could be for each item, but convention is to just have one letter. So ordered by I. So for item, for each item, let's order it by the item.id. And then finally, let's put this into a list called found items. So again, we're loading all of our item data scriptable objects that we've created that are going to be in a folder called item data. And then we're going to sort all of those inventory items. We're going to order them by their ID, and then we're going to put them into a list called found items. And now we need to filter these found items into 3 separate categories. We need to say has ID in range. That's going to be one of the categories. We're going to has an ID not in range. I'll explain these all in a second. And we want no ID as well. So here we're seeing whether, say we found 10 items, but for some reason, tomatoes had an ID of 5, but then potatoes had an ID of 15. The one that has an ID of 5 would be in range because it's in the range of the amount of items that we found. The ones that had an ID of 15 or anything above how many found items we had, they would have a valid ID, but it wouldn't be in range. And then no ID are going to be all new items that we've never set an ID for before. And we're going to default them. And when we make a new inventory item data, we're going to make it so it always defaults to -1, which is what we can then check for. So let's focus on has ID in range first. So I'm going to set this variable equal to found items. So we're going to check this list and we're going to get all the ones where our item ID is not equal to -1 and the item's ID is less than the found items.count. And then we're going to order that list by their ID, so just the same as above, and then we're going to put them all into a list. And this seems quite complex in terms of, memory usage. It might not be the most efficient, but this is only going to get called when we build the game. This is never going to happen like in-game where there's a player doing this. So for our purposes, as long as it's functional, I'm more than happy with that going into a built version of the game. So for the not in range, we're going to do the exact same thing, but we're going to change the check on the count. So we can say equals found items where their ID is not equal to -1 and the ID is greater than or equal to the found items.count. And then we'll put that into an ordered list. And then finally, we're going to copy our found items where. And we're going to say where the item ID is less than or equal to -1. And we'll put that into a list as well. So now we're going to loop over all of our lists and organize them into the item database in the correct order. The ones that don't have an ID, we're going to give an ID. And because they're scriptable objects, this ID will then be persistent. That data will stay. We don't need to save it out to a list, like to a JSON list or anything like that. So I'm going to make a temporary index variable, just called index, and we'll set that to 0. And then I'm going to go into a for loop. I'm going to say for int I, and while I is less than the found items.count, so all of the items in our game, I++, and I'm going to make a new inventory item data called item to add, because dependent on some different checks, this is going to decide what item that is that we're checking, and then we'll put this item into the list. So here, we're just checking the ID at I. We're going to check the found items.range, and we're going to see if the item that we're looking at has the same ID as the position that it's come through into the ordered list. So we're going to say item to add is equal to has ID in range dot find, and I'm going to say where the data, and I'm using D here instead of I because we've already got I here. I'm going to say where the data is equal to the data's ID equaling I. Sorry, that's not equal. It needs to be that. So when we've got to this index that we're on, we're going to assign it we're going to assign it an item from this list. This has ID in range list. So we're going to get the ID that matches the current iteration of the loop that we're in. If the item to add is not null at this point, then we are good. We can add that item to the database because it's the correct item in the correct position. So item to add can go into the database. If the item to add is null, so we've not found an item that's within the range that we're looking for, doesn't have a correct ID, then we're going to check, does the index, which is this variable here that we've made, is the index less than the ID, is less than the no ID dot count. So this is a separate index that we're keeping track of over here because we're only going to iterate this when we run this bit of code to make sure that we don't go out of range of this no ID list. So if there's no ID, what we're going to do is we're going to get the item that is at the index that we're looking at, and we're going to set its ID equal to I. And again, I is the current loop index. So essentially we're going to get, the first time around, if we get to here, we're going to go into this list of no IDs and we're going to get item 0 and we're going to set it to the relevant ID of this loop. And then we can say item to add is equal to no ID dot index. We will increase the index. So this is the sort of internal index to this no ID list. So we're going to increase the index and then we can add the item to add to our item database. So item to add goes into the database. And then once this has ran and we've gone completely through this loop, all we're going to do then is we're going to go through all of the items that have an ID but they aren't in range. So we'll say for each item in has ID not in range, we're just going to add them to the end of the list. So item.database.add item. So this will be a case of, say you had 15 swords in your game and you decided that's too many, I'm going to take out 5. But you're only going to take out kind of like the middle 5 and then the last sword, which was originally the 15th sword and had an ID of 15. Players have that, testers have that. You don't want to remove that ID from the database because it might be referenced in a save file somewhere. Doing this ensures that those IDs don't have to change. They can still be valid. And if you add more items into the future, it's going to fit it into kind of the next available slot in our list. So that's the setID method complete. So now all we need is a method that returns some inventory item data, and we can call this getItem, and we can just pass in an ID. And all this is going to do is return the item database.find, and it's going to find the item that has the ID that we've just passed in. So find the item where the item.id is equal to ID, which is this ID here. Because once we run this set item IDs, because it's a scriptable object, the item database will just stay around until we call set item IDs again. So we don't need to run this at runtime. We can just run this the once when we build the game or while we're testing the game in the editor, and then that's all we need. That's all we need to do. So let's save our database and let's just go back to our project. So now you need to make a folder called resources. So I'm going to create a folder and let's call this resources. And I'm actually going to put this into our item scripts because you can have multiple resources folders. So remember, we were looking in a folder called item data. I'm going to put all of our scriptable objects, so the potato and the tomato, I'm going to put this into our item data folder. And in the root of our resources folder, I'm going to create inventory system item database, and I'll just call this database. So whatever you name this is what you're going to refer to it as in some code later. So make sure you name it appropriately. Call item database. I'm just going to leave it as database. So you can see here that our list of items is empty. We've got our item data here, and their ID is currently set to 0. Let's just set these to -1. And let's actually open up our inventory item data. And I'm going to set this equal to -1. So when we create a new inventory item, it will be automatically set to 1. So let's do inventory item, and I'll call this apple. So you can see ID is set to -1. And we'll just type in apple here. So if we go back to our database, so I'm going to set the potato. So these are all -1. So if we go to our database and we come up to the 3 dots here, you can see that it's got set IDs, and this is what we did with that context menu. If we hit that, you can see that it found all of the items in the item data folder. It found 3 items. It found apple first. So this is ID 0. ID 1 is the potato. ID 2 is the tomato. And that matches element 0, element 1, element 2 from the database list. If, for example, this was set to, this one was 0, we'll put this one back to -1. And I'll put this at 50. So it's going to find all of the items, but it's going to put them into their ID order. So this is ID 0, so it'll go into element 0 in the list. And then it'll find this one has -1, and element 1 doesn't have a matching ID, so it's basically a free. So it's basically an ID that is free to be assigned to another item. So it'll set apple to 1, and it'll leave ID as for the tomato as 50, and it'll just put it at the end of the list. So let's go back to our database, and let's just set the database back to 0. So if I click set IDs, so you can see element 0 is the potato, which had an ID of 0. It set the apple to ID of 1, and tomato has been left at an ID of 50. So if I create another inventory item, and I'll call this pair. We'll do display name pair, and I'll leave the ID for now at -1. So what we need to do now is we need to load our items back into the game based on their ID, not their instance ID. So let's go back over into our IDE, and we're actually going to go over to the inventory slot.cs file. And here we're going to implement the iSerialization callback receiver, which is an interface that allows us to get a callback when the game is being serialized, that we can get a callback. So just before it's serialized and then after it's serialized. And we'll implement the missing members, which are these two scripts here, which are these two methods here: is public void on before serialize, public void on after deserialize. And we don't care about on before serialize. We don't need to use that, but we have to keep it around though. So I'm going to get rid of the throw exception. The method that we're going to use is on after deserialize. But first we need to go back up and we need to assign an inventory ID to our slot. So serialize field, private int, and we'll call this item ID, and we'll default this to -1. So when we save out our inventory system and all of the inventory slots, we're not actually going to be saving out the items contained within the slot anymore. We're just going to be saving out this int, which will correspond to an item in the item database. So this can be private, but it has to be serialized with serialize field. 1, so we can see in the inspector, and 2, so it saves out into our JSON save data. So let's go back to on after deserialize. So here, I'm going to check whether the item ID is equal to -1. If it is, the slot's empty, so we don't need to get the item data. And instead, what we can do is I'm going to make a temporary variable called database. And I'm going to set this equal to resources.load. I'm going to load the database from our resources folder. And it's going to be called database, because it's called database and it's in the root of our resources folder. What you may want to do is load this database into memory on your game manager or on some sort of singleton somewhere, just so you can always access it. You're not having to load it each time the game deserializes. But for the purposes of this is fine. And then all we're going to do is say item data is equal to the database.getItem, and we'll pass in our item ID. So now let's go up to the assign item method here. So this is when we pick up an item and we're assigning an item to the slot. What we want to say is, so the data is equal to the data, and our item ID is equal to the item data's ID, which is the ID that was set to it by the database. In clear slot, we just want to set the item ID back to -1, because the slot will be empty. And when we create a slot in the constructor, we just want to set the item ID to the ID there as well. And we just want to put item ID into the update inventory slot as well. So that should be that. Let's go back over to Unity and just check that that's all working. So let's hit play. Let's pick up some tomatoes and potatoes, go over to the player, and you can see here that we've got the tomato and it's got an item ID of 50. Got the potato, item ID of 0. And then the slots that are empty have an item ID of -1. So I'm going to delete my old save file because again, we've done some structural changes to the way stuff is saved. And I'm actually going to hit save here. And let's load up that save data. So here you can see that item data instance ID is still being saved out. We don't need it to. In fact, it's confusing that it is, so let's just mark that as non-serialized. So in our inventory slot, instead of serialized field, we can do non-serialized. But you can see that the rest of it, we've got the item ID and the stack size, so it's loading it in by item ID and not by the item data's instance ID. So this will never change, this could change. So let's just check that again. Let's delete our save. Let's pick up some stuff. Let's put it in a chest over here. And we'll hit save. Let's check that save. So here we've got our chest inventory. And you can see that it's just saving out the item ID and the stack size. It's not got any of the instance ID stuff now. So we've saved that. Let's come back out of the game, go back in. Let's hit load game. So there's our potatoes, everything deleted off the floor. We've got our chest, which is where we put the tomatoes originally. I'm just going to split that stack, put it over here, put them in there. So I'm going to save the game, and let's just check that it all works in the build version of the game as well. So I'm going to come over to our database and make sure we set the IDs. If you want to see how you can automate this and get the database to set when you hit build, click the little icon in the top of the video now. I covered that a couple of days ago. I covered that in a previous video. Just follow through with that and you should be able to see how I got the database to save when I hit build. It will search for and add all the items to the database that I may have forgot to put in myself. And you can see that if we've hit build and run, we're in the game, we hit load, and now our save files kind of in sync between the actual player and the editor. And you can see that there's our tomatoes. Got these tomatoes here. Let's put a potato in. Come out of that. Let's just save our game again. Alt F4 to quit. We can press play here. Hit load. And the save files are now in sync, which is great for debugging. So later on as your game progresses and you start to get beta testers, if they say, oh, I've got this weird bug with my game, they can now send you the save files. You'll be able to load it up in the editor and start to debug what exactly is going on. So I hope that was useful for you. I'm glad I caught that bug, and thanks again to the commenter for letting me know about it. For the future of this inventory tutorial series, I'm currently prototyping a shopkeeper system, so you'll be able to sell items at a shop to make some gold. That's currently in the prototyping phase. It depends when this video comes out and how far I've got with that and what else has gone in life, when that will be. But subscribe if that is something that you'd like to see. If you want the project files for this tutorial or any of the other tutorials on my channel, you can get them over on patreon.com/danposs. There's a link for that in the description below. If you need any help with this tutorial or any of my other tutorials, you can come over to the Discord again, which is linked in the description below. But in the meantime, thanks for watching, and I'll see you in the next one. Bye.